Many people ask, especially on YouTube, that if electrolyzed water is a low concentration of Clorox, is it correct to understand that Clorox does not have hypochlorous acid, but electrolyzed water does?
That is a little different. To say that this is the same as Clorox is not something a knowledgeable person would say. Electrolyzed water does contain a substance similar to Clorox in some parts, as salt is used and Clorox is made by decomposing salt as well. We call it a high-concentration sodium hypochlorite generator, though. To make it, salt is put in an electrolyzer with a membrane and is decomposed. This membrane induces a reaction inside while causing pH change, so that acidic water and alkaline water are divided, and by doing so, hydrogen is generated at the cathode. As hydrogen is produced, a substance is created, and oxygen is generated at the anode, which produces chlorine. So chlorine is produced on one side, and hydrogen is produced on the other side. On the side where hydrogen is produced, so-called positive ions, sodium, calcium, magnesium, and potassium, are attached to form NaOH, which is also known as caustic soda, or lye, in water. On the other side, chlorine gas, called Cl2, is generated. Then these two are guided with a tube to react with each other in the space of gas. This is called a gas phase reaction, and through this gas phase reaction, a high concentration of sodium hypochlorite of about 12%, which is 120,000 ppm, is produced. Of course, the sodium hypochlorite produced in this way is significantly affected by the storage method, storage temperature, and places. Even though it is formed with 120,000 ppm, it does not continue to last in that concentration, but is significantly decreased within 20 days, or after 14 to 15 days. The concentration is decreased by about 10%. The problem is storing such high concentration substance. I don't think this is the part I can cover, as there are many others who have more expertise in this area. Sometimes one's opinion can sound helpful, to it can also be damaging to others. As one of those who are in business, I can't just talk about the weak points of others' areas. Anyhow, there is a method of generating high concentration sodium hypochlorite, and now there is a method for generating low concentration sodium hypochlorite.
Are the methods different?
They are totally different. The method for generating low concentration is intermediate than what I mentioned earlier. This is between 8,000 ppm and 10,000 ppm, and most electrolyzed water in Korea, Japan, and China are produced with this method. A concentration of about 0.8 to 1%, 1% being 10,000 ppm and 0.8% being 8,000 ppm, is produced to be mixed with water, resulting in 99.99% of pure water and 0.01% or electrolyzed substance. This is also a high concentration, though. 0.8%, which is 8,000 ppm, or 1%, which is 10,000 ppm, concentration is mixed, resulting 99.99% of water and 0.01% being this high concentration. Another method is to electrolyze the entire water. This is not with 0.2% of salt water, but is to decompose 0.02% of salt water.
Is it 200 ppm?
Yes, as it is produced by decomposing that, this is really low concentration, even lower than the one I just mentioned. This method is used not to cause any possible problems. When I talk about electrolysis, I say that electrolyzed water is what we need. For this to universally used in human life, preventing side effects or any possible damages is something that I always think. A lot of people wonder how this is different from Clorox, but as we just talked about, knowledgeable people would not say such a thing. First of all, Clorox has a different nature. It has a different pH, which is around 8 or 12. Also, Clorox can be stored for a very long time in that high concentration state. The concentration of Clorox is thousands of times more than electrolyzed water we make. It is 12,000 ppm, and what we make is 200 ppm. That is already a big difference in numbers. As per the standards of MFDS, or the guidelines of MOE, Fruits and vegetables are placed in Clorox for 5 minutes and rinsed before use. In the test regarding this, the difference of electrolyzed water and Clorox was about 80 to 100 times in residual substance. The residual amount of chlorine in electrolyzed water is 80 times less. It almost means that there is no residual substance. MFDS advises rinsing more than 3 times under clean water when using Clorox because of that residual substance. With electrolyzed water, even with the same 100 ppm, it is almost the same as being rinsed 3 times.
So, does that mean that it is most similar and close to pure water?
I wouldn't say it like that, but when something is disinfected or treated with it, there are no byproducts left, which means that it is not harmful to our health. Another thing is that when cut vegetables are rinsed with it, vitamin destruction is only 1/3. If 100 is destroyed with Clorox available in the market, only 30 is destroyed with electrolyzed water. It is not even comparable when talking about toxic gas, as 200 ppm of Clorox would provide a very unpleasant smell.
Is the gas chlorinated gas?
It is chlorine gas. Yes, chlorine gas. When Clorox is met with acid, chlorine gas is immediately produced. Of course, if you are careful when using it, there is no problem. I've already explained the reason why I keep saying that Clorox is not too bad.
Is it correct for me to understand that Clorox itself is not that harmful, but electrolyzed water is something that is made much less harmful?
Yes, for example, the residual chlorine is only 1/80th when used under the same concentration. That is one of the advantages of electrolyzed water. Other advantages are less vitamin loss and no toxic gas being generated. Clorox can cause problems when cleaning bathrooms because of its high concentration dilution. That's not because Clorox is bad, but it's inevitable due to its properties. Hence, we need to be careful when using Clorox. Although, with such issues, Clorox has been protecting human health until we were able to discover electrolyzed water, and we should acknowledge that. Just saying that they are not the same and lower ppm is better would not make sense. Do you think 30 ppm of Clorox would provide disinfection? It does not work that way, and that is why it is instructed to use 100 ppm of it. That 100 ppm is also known as BP, which is the boiling point, and it is the level where bacteria are killed and still being safe to humans. That is because it has to provide a maximum effect on humans. Then is only Clorox bad? No, anything in this world becomes bad if the concentration is increased. For example, there is oxygen. Everyone knows that oxygen is good for us, but sometimes it can be bad. What makes humans age and what destroys brain cells is oxygen. There are many dualities of oxygen, and of course this is when the concentration is too high. That is why on this planet only 20.9% is oxygen and 76% is nitrogen gas, with others being formed of hydrogen, helium, etc. Even this so-called good oxygen can become fatal to humans when the concentration is very high. That is why the problem is with the concentration. If we only use the concentration we need, that is fine. In fact, there was nothing available for us besides Clorox in the past.
This electrolyzed water is made with neutral pH. Usually, other electrolyzed water is slightly acidic or alkaline, because in this case, the detergency is increased. This is maybe because Clorox is used a lot for cleaning, resulting in most electrolyzed water to be like that. Is there a special reason for making yours neutral?
It is not because I wanted to make it neutral, but it just naturally happened. Of course, I started with making it slightly acidic or alkaline for my research studies 30 years ago, but it became inconvenient for commercial use.
For example?
It becomes either acidic or alkaline from pH change with the membrane, which requires the maintenance of the membrane, makes the structure complicated, and costs a lot. That is why I decided to leave the membrane out and continue with my research studies to be able to reach where I am today. Nowadays, most countries are maintaining without membrane. I am saying that it is what it is now, but to change the pH of water, the membrane must be present. For example, if we don't have the military demarcation line, How can we distinguish South and North Korea? It is the same for this. The membrane makes it acidic and alkaline.
It is like a layer.
Yes, the membrane is like a layer, but with a lot of porosity. As it is very porous, ions can move around, but water can't. Hence, it divides the pH into being acidic and alkaline, with that membrane as the base, causing not only inconvenience, but making water having two very different properties. That may be good, but also bad sometimes. For example, if I need strong acidic electrolyzed water, I need to either get rid of or store strong alkaline water. On the opposite, if I need strong alkaline water for cleaning, I need to get rid of or store strong acidic water. This is why I thought the commercial potential is low and decided to go without the membrane. As we talked about previously, OH is 2.81 and HO is 2.84, which is quite high. HOCl is 1.49 eV, which means its oxidation potential is slightly higher than NaOCl.
Can we understand this oxidation potential as electrical energy?
It is a type of electrical energy.
Can we call it as electrical energy?
Yes, oxidation and the oxidation potential is a form of breaking something. You know how people say that the universe continues its creation and extinction? This extinction corresponds to oxidation, and the creation refers to deoxidation. So, ORP represents the potential of oxidation and deoxidation, and this potential represents the energy of the force that can be converted. That is why it's very important. If you look at the oxidation potential of fluorine, it is very high, as 2.8 to 2.9.